Okay, let's first look at how we graph two variable functions or double variable functions. Okay, one recommendation is that you always try to remember how you graphed the one single variable function. Now you may say, well, I just plot points and then I connect curves, but that's not going to be the way we're going to do actually two variable functions. So try to remember the shape of the simple single variable functions. That way we can actually go to a higher dimensional. Now, let's first look at an example over here. Of course, it's already written over here, it's a plane, but we're going to explain a little bit how we're going to actually do this. So first of all, you need to draw a three-dimensional coordinate system. Okay? And this is the way we do it. And this is X, and this is Y, and this is Z. Okay. So in general, this Z is equal to f of xy. It's going to look like a so-called a surface, because suppose you have a domain over here, pick an x, y over here, and you find a value, and this is f of xy, right? So if you let this z change, and then you can have something like this over here on top. So maybe it's like a tent, right? But we are not going to go that complicated. Let's try to look at a simple one. Say we have f of x, y, two variable, and it's going to be 2x plus 3y minus 6. This is linear, so-called linear, right? Because you have 2x and 3y, and it's constant. Okay. Now try to remember what we did in single variable function. At that time, suppose we have something like this. We have, say, y is equal to 2x minus 6. And then we say this is slope and this is the intersection. And this is what we have. When x equal to 0, it's negative 6 over here, and slope is 2. So this is how we do it. It's a line. Now, you may think 2x plus 3y minus 6 is going to be another line, but you will see, actually, because we are now in three-dimensional space, it's not going to be just a line. Now, let's first look at something simple. For example, suppose we have z is equal to 0. So what is this? Z is equal to 0. That means for all values of x, y is 0. And so this is actually xy plane. So that's why when you have 2x plus 3y minus 6, this is going to be a plane. Of course, it's not going to be a coordinate plane, but it's going to be a plane. It's slanted. Okay. And similarly, if you have, say, z is equal to 1, this is still a plane. But of course, it's elevated. It's 1. Okay. Now, in general, how do we do this? We have a very simple way. We look at interceptor method. So we look at what's going to happen if x is equal to 0, y is equal to 0. That's on the z-axis. This is on z-axis. And if x is 0, y is 0, you see z is going to be equal to negative 6. So what you have over here, you can say, oh, I'm going to have negative 6 over here. You extend it and put it negative 6 over here. And this is a point. And then you try to use all combinations. Now we're going to look at x is equal to 0 and z is equal to 0. And that's y-axis. Okay, now if x is equal to 0, z is equal to 0, then we're going to see that y is going to be equal to 2, because we can actually solve it over here. Z is 0 and x is 0 and plus 3y minus 6. So y is equal to 2. So then you put a dot over here, okay? And similarly, you try now, look at what's going to happen if y is 0 and z is 0. That's going to be on your x-axis, okay? And then you actually will see that because y is 0 now, the x is going to be equal to 3. So here you're going to put a 3 over here. So these are the intercepts. Now, how can we graph it? It's going to be difficult to do, but we can connect them up. Okay. Now, you have to imagine this is 3-dimensional, and actually this plane intersect this so-called octant over here. You form a triangle, but it's a plane actually extends everywhere. Okay, so this is going to be the plane. Sometimes it helps if we actually put some kind of lines inside to indicate this is a plane. All right, and all the planes can be done essentially in this way. You may say, how about z is equal to 1? You can draw a parallelogram over here like this. Okay, so this one over here, z is equal to 1. And x and y, they are not limited. All right, by the way, we can only do very simple ones at first, and we cannot possibly do very complicated ones. So let's stop over here. In our next example, we're going to show maybe 2 more examples how to sketch the graph of not just a plane, but some familiar shapes of simple functions.